I have to say, looking at the stack of research for today, I honestly thought there was a filing error.
Yeah, I had the exact same thought when I opened it.
Right. Because usually we're digging into, tech specs, economic trends, maybe some high-level management theory, standard deep dive stuff.
Yeah.
But it's just different.
It is definitely an outlier in the stack. It's not every day we get a technical white paper that reads, well, kind of like a philosophy lecture.
Exactly. So for you listening, we're looking at a document released by a group called Roots BIM LLC. It's a technical reflection piece, but it was released specifically for Good Friday 2026.
Which is an immediate flag that this isn't your standard manual.
Right, and the title is Sacrifice and Structure, Engineering Integrity Through BIM Leadership.
Yeah.
So on one hand, we have Good Friday, that's highly theological, somber. It brings up this whole idea of sacrifice before resurrection.
Heavy stuff.
Very heavy. And on the other hand, we have BIM, Building Information Modeling, which, let's be honest, is usually associated with what? Clash detection software. Spreadsheets.
3D geometry, yeah.
It is a really bold, maybe even slightly weird crossover.
It sounds totally disjointed at first. Like they're maybe trying a bit too hard to be profound with something that is usually incredibly dry.
Right.
But once you get past that title and actually read the reflection, the central argument is surprisingly practical.
I thought so too.
They're taking this very old, very heavy concept that new life or a new creation absolutely requires a preceding sacrifice, and they're applying it directly to the total chaos of a construction site.
It's the idea that a building doesn't just, magically rise out of the ground because we want it to. There's a massive cost.
Exactly. The resurrection part of the metaphor, the visible, shiny building opening its doors, the ribbon cutting, the mayor smiling, that is the easy part to celebrate.
Everyone loves a ribbon cutting.
Of course. But this document is completely obsessed with the Good Friday part of engineering. The invisible suffering.
Grind.
The grind, the data entry, the incredibly uncomfortable coordination meetings where people are just arguing about ductwork for 3 hours. The central argument here is that you simply cannot have a structurally sound building without a massive, invisible sacrifice of data discipline beforehand.
And that, right there, is our mission for this deep dive. We're going to strip back the drywall, so to speak, and look at this invisible load-bearing layer.
I like that framing.
We need to figure out if this is just really clever marketing language or if treating data entry as a literal moral sacrifice actually changes how you build.
And I think it does.
Because if they're right, it kind of changes how you look at every single skyscraper you pass on the street.
Absolutely. And for the engineers listening, or anyone managing complex projects really, this whole concept reframes the most tedious parts of your day.
Gives it meaning.
Exactly. It turns the grind, the stuff you absolutely hate doing, into the actual structural foundation of the project.
So let's actually start with that foundation.
Sure.
Section 1 of the piece introduces this concept of the invisible load-bearing layer. Now, normally when I hear load-bearing, my brain immediately goes to concrete columns, steel beams, the stuff that physically holds the roof up so it doesn't crush us.
Invisible structure.
Yeah, but Roots BIM argues that the visible physical structure is really just the final chapter of the story.
They're essentially saying that by the time you see a crane on site, the war is already over.
The war is over.
Yeah.
Yeah.
If you're fighting the battle while the crane is swinging and the hourly meter is running, you've already lost. The real structural work happened months, sometimes years ago on a server.
They use a specific comparison here that I want to unpack because it's dense, but I think it's the key to the whole piece.
Go for it.
They write, before a column carries an axial load, the model must carry the coordination load.
That's a great line.
It is, but let's break it down. I get axial load. That's gravity. That's just physics pushing down.
Sure.
But coordination load feels a bit abstract. What does that actually weigh?
Okay, think of coordination load as a stress test, but for logic instead of steel.
Logic instead of steel.
Right. A physical steel beam has to hold up a physical floor. A digital model has to hold up the conflicting demands of 50 different stakeholders.
Oh, I see.
The architect wants really high, beautiful ceilings. The mechanical engineer needs massive air ducts to meet code. The structural engineer needs deep beams to hold it all up.
And they all want to use the exact same space.
Exactly. All those things want to occupy the exact same cubic foot of air. So the load is the immense invisible pressure of validating that all those competing visions can actually coexist in the same laws of physics.
And if the digital model buckles under that coordination load,
Then the physical building fails. Maybe not structurally. I mean, hopefully not. But it fails financially. It goes millions over budget, or the schedule slips by a year.
Right.
The document actually lists the specific components of this load, and they are not trivial at all. They talk about federated model validation and the climb from LOD 100 to LOD 500.
Let's pause on the LOD thing. Level of development. I think a lot of people, myself included, kind of assume a 3D model is just a 3D model. Like, it looks like a building on the screen, so it is a building?
That is the most dangerous assumption you can make in construction.
Really?
Oh, absolutely. LOD is a scale of reliability. LOD 100 is basically a placeholder. It's a generic gray block that says chair or water pump.
And it's just taking up space.
Right. It has no specific information. LOD 500 on the other end is the as-built reality. It has the manufacturer, the serial number, the exact dimensions down to the millimeter, the maintenance schedule.
Wow. Okay.
So the sacrifice this document is talking about is the sheer number of man-hours required to drag a model from a vague idea at LOD 100 all the way to a verified reality at LOD 500.
It's the difference between a napkin sketch and a literal manufacturing order.
Precisely. And imagine doing that for every single pipe, light switch, and beam in a massive hospital.
That sounds exhausting.
It is a heavy load, it's tedious, it's incredibly boring, but it's the sacrifice that makes the building work.
They also mention clash matrix resolution loops. Now, that sounds like a truly miserable way to spend a Tuesday afternoon.
It is miserable, and that is exactly the point they're making. A clash matrix is basically a grid. Structural versus mechanical, plumbing versus electrical. You run the software, and it spits out a report telling you there are, say, 5,000 instances where things are hitting each other.
5,000? That seems really high.
Honestly, on a complex project like a lab or a hospital, 5,000 is a light week.
You're kidding.
Nope. And the resolution loop is the absolute grind of fixing them one by one. You move the air duct so it doesn't hit the beam.
Simple enough?
But now the duct hits the electrical cable tray, so you move the tray, but now it hits the fire sprinkler pipe. You move the sprinkler, and suddenly you violate the fire code requirement for ceiling height.
Oh, wow. So it's a domino effect.
Exactly. You go around and around in this loop. That is the suffering the document refers to. It's pure mental endurance.
So when they say the model carries the load, they really mean the model, and the actual human beings managing it absorb all that chaos early on so the guys with the hard hats on site don't have to deal with it.
Spot on. Because if you don't resolve the clash in the digital matrix, you end up resolving it with a jackhammer on the actual site. And concrete is a lot harder to move than pixels.
That makes total sense. They also throw in 4D sequencing simulations, so we're adding time to the equation here, not just 3D space.
Right, because physics isn't just about where things are, it's about when they get there. Two things might fit perfectly in the same space in the finished building, but not at the same time during construction.
Like what? Give me an example.
Well, you can't install a massive room-sized industrial boiler if you've already built the brick wall that blocks the doorway to that room.
Oh, right. It physically won't fit through the door.
Exactly. So 4D simulation forces the team to build the entire building virtually, step by step, day by day. It catches those logistical timeline clashes.
It really does sound like a form of extreme endurance training for engineers.
It really is. Roots BIM actually calls it structured effort before structural emergence. It's an acknowledgement that clarity isn't free. You pay for clarity with sweat during the digital phase.
Which naturally brings us to the ethical side of this whole argument. This is where the document shifts gears from process into integrity. Section 2 is titled Truth as a Technical Principle. And I have to admit, I love it when engineers get philosophical about truth.
This is hands down my favorite part of the text, because it completely stops being about software features and starts being about fundamental honesty.
They use a phrase here that jumped out at me, the digital covenant. Not a digital contract, a covenant. That's biblical language making another appearance.
It is, and I think it's highly deliberate. Think about it. A contract is purely transactional. I do this specific task, you pay me this specific amount of money. But a covenant implies a deeper relationship. One that can't be broken just because things get difficult or inconvenient. In construction, a standard contract says, I'll build this structure for X dollars. A covenant, in the specific BIM context, says, I promise you that what I am showing you on this screen is the absolute truth.
Their golden rule for this covenant is, if it exists in the model, it must survive on site. Now, playing devil's advocate, that seems kind of obvious. Like, why would you take the time to put it in the digital model if it's not actually going to be built on the site.
You would be shocked at how often this happens. In the industry, we call it the gap between design intent and means and methods.
Design intent.
Yeah. Often, an architect or even a junior engineer will model something just to show, hey, there should probably be a pipe generally in this area. It's just a placeholder.
So it's not real.
No, it physically floats in midair in the model. It doesn't connect to a wall. It doesn't account for gravity or the steel brackets needed to hold it up. It's what this document very scathingly calls ornamental modeling.
Ornamental modeling. That sounds like a very polite corporate way of saying fake.
Oh, it is absolutely intended as an insult in the engineering world. It means you're just decorating. You are not engineering.
You're just making it look pretty.
Right. You're making a pretty 3D picture for the client presentation so the owners smile and sign the check. But you are handing a total lie to the builder who actually has to make it stand up. Roots BIM is taking a hardline stance here. No decorative coordination allowed. If you put it in the model, it must be physically buildable.
So if I draw a steel beam in the model, but I haven't actually checked if it fits around the HBIC system, I've broken the digital covenant.
Exactly. You've created a digital fiction. And the document actually asks some pretty brutal questions to test this integrity. One of them is, are reinforcement densities actually constructible or just theoretical?
Okay, you're going to have to translate that one for those of us who don't pour concrete for a living.
Sure. So a structural engineer calculates the heavy load on a concrete column. The pure math says, okay, you need exactly 20 thick steel bars inside this column to hold the weight of the roof.
Makes sense.
The engineer puts those 20 bars into the digital model. But in reality, if you put 20 bars into that specific size of a column, they are packed so tightly together that the actual rocks in the liquid concrete mix literally cannot physically fit between the gaps in the steel.
Oh, wow.
Yeah, you literally cannot pour the column. The concrete will get stuck, it will be full of air pockets, and the column will eventually fail.
So the model is perfectly mathematically correct on the computer screen, but physically impossible in the messy real world.
Exactly. It's theoretical, it's not constructible. Under this digital covenant they're talking about, that model is a lie. You are promising the client a column that cannot be built safely.
So what's the fix?
The sacrifice is taking the extra time to space those bars out properly. Maybe you have to make the overall column bigger. Maybe you have to change the entire concrete mix design to use smaller rocks. And you have to do all of this before you issue the final drawing. It's doing the deeply hard work of validation upfront.
They also ask about reactive versus rule-based MEP clearances. MEP being mechanical, electrical, plumbing.
That's all about discipline. Reactive modeling is just drawing a duct wherever it fits easily and checking later to see if it hits a wall. Rule-based modeling is doing the hard work to set up the software so it actively forbids you from drawing the duct in the wrong place to begin with.
Oh, I see.
It's submitting your design to the harsh rules of reality before you even click the mouse to start drawing.
It really feels like they're trying to violently close the gap between the virtual space and the real world. I think for a long time we've just treated the digital model as a glorified sketch. A nice suggestion.
And that exact gap is where all the money is lost on a project. That gap is where the massive lawsuits happen. Roots BIM is simply saying, close the gap. If it's in the model, it is a binding promise. If you aren't sure it works, do not model it.
This level of intensity leads right into Section 3, which is all about eliminating digital conflict. They title this section, From Suffering to Stability. They are really leaning hard into this Good Friday metaphor of suffering leading directly to redemption.
They are, but honestly, it tracks perfectly. The suffering is the conflict resolution. It's the sheer pain of forcing yourself to solve complex problems early instead of kicking the can down the road.
They compare traditional workflows to advanced WIM workflows. And the core difference just seems to be when you actually find out you're wrong.
And that is the only difference that matters in construction. In traditional workflows, conflict is discovered very late. We call it clash by fire.
Clash by fire. That sounds expensive.
Highly expensive. You find out the plumbing pipe hits the steel beam when the pipe fitter is literally standing on a ladder, holding the heavy pipe, looking at the beam, and realizing they occupy the exact same physical space.
And at that point, you aren't just deleting a digital line in AutoCAD.
No, you're burning thousands of dollars an hour, you're delaying the entire project schedule, you're filing RFIs, requests for information.
Which are what, exactly?
RFIs are basically official, legally binding admission forms that the original design was incomplete or flawed. It's a chaotic process, and at that stage, everyone is angry and pointing fingers.
Versus the advanced workflow where they say, Conflict is proactively hunted down.
Hunted is the absolute right word for it. You aren't just passively waiting for software to flag clashes. You are actively trying to break your own model to find the weak points. They have this great ruthless quote in the text. Clashes don't happen. They are either designed out or allowed in.
That is incredibly harsh. It removes the entire excuse of saying it was just an accident.
It demands total, uncompromising responsibility. If a clash exists in the field, it's strictly because you let it stay there in the model. You allowed it in.
So how do we actually hunt them down? The document lists some very specific software tools: AI-assisted rule-based modeling and automated clearance zones.
Think of clearance zones like invisible force fields.
Hmm.
A giant water boiler isn't just a solid metal box. It needs 3 feet of empty space in front of it, so a human technician can actually open the access door and fix it 5 years from now.
Right. You need room to work.
Exactly. So in the digital model, you can create a literal invisible volume, a digital bubble that represents that required human space. If another designer runs a pipe through that invisible bubble, the computer screams at them.
So you're modeling the empty space itself, not just the solid materials.
You're modeling the future operations. That's what designed out means. You aren't just designing a static machine, you're designing the maintenance of the machine.
They also mentioned parametric logic. Now that sounds like pure buzzword bingo to me, but I have a feeling it's actually important.
It's actually one of the coolest parts of modern BIM. It means the building elements are connected by underlying logic, not just their visual placement.
Give me an example of how that works.
Okay, if I decide to move a brick wall 3 feet to the left, the parametric logic ensures the window inside the wall moves with it automatically. The electrical outlets move with it, and the spreadsheet counting the total number of bricks for the purchasing order updates instantly.
That is smart.
It ensures that a design change in one place propagates the exact truth everywhere else simultaneously.
So you don't end up with a scenario where the wall is over here, but the windows are just floating magically in midair where the wall used to be just because some junior designer forgot to select them when dragging the mouse.
Exactly. It completely maintains consistency. But using these powerful tools, and this is a huge point they make, requires what the document calls restraint, patience, and humility.
Humility is a really interesting word choice for engineering. Engineers aren't exactly world famous for being deeply humble people.
Fair point, but it's essential here. You have to be humble enough to let the computer tell you that your brilliant design is actually wrong. You have to be patient enough to sit there and methodically resolve 500 individual clashes in a matrix resolution loop when you'd really rather just clock out and go home.
That's the sacrifice coming up again. Giving up your own ego and your free time for the sake of the project's ultimate stability.
It's truly invisible work. No one ever walks into a beautiful new building, looks up at the ceiling, and says, wow, look at all the pipe clashes that aren't here.
Right. They just see a ceiling.
You only ever notice coordination when it fails. True success in this field is absolute silence.
That is actually a perfect transition to Section 4, which is titled Purpose and the Silence Before Execution. Because at some point listening to all this, you really have to ask why. Why are we doing this? Why go through all this immense pain and suffering in the digital phase?
Right. Is it really just to save some wealthy developer a bit of money on the back end? Roots BIM forcefully argues it's far more important than that. They state that a model without a clear purpose is just geometry. But a model with deep intent is infrastructure stewardship.
Stewardship implies we are taking care of something that actually matters to the public. It's not just about corporate profit margins.
And look at the specific examples they list in the text. They aren't talking about luxury casinos or high-end condos. They specifically list healthcare resilience, educational infrastructure, and major water management systems.
When you frame it that way, a pipeline clash isn't just a minor data error on a screen.
No, not at all. If a massive clash in a hospital design delays the construction schedule by 3 months, that's 3 months the local community does not have an operating emergency room. That is real human lives.
That changes the perspective entirely.
If the main water pumps aren't perfectly coordinated with the electrical power supply in a municipal treatment plant, that's a citywide sanitation crisis waiting to happen. The digital sacrifice of the engineer directly protects the public.
They describe the specific phase right before physical construction starts as the silence before resurrection. I really love that visual image. It's the calm before the storm.
It's the quiet confidence of knowing you are truly ready. In a poorly managed project, the time right before construction is pure panic. Everyone is rushing, changing orders, stressing out. In a sacrificial project where you've front-loaded all the hard work, it's silent. You simply know the building fits together.
They actually list a hidden checklist of things that create this silence. We've talked a lot about physical clashes, but they also mention model health audits and data schema alignments.
Data schema alignment is a massive sleeper issue. It basically implies that we need to make absolutely sure the computer network speaks the exact same language as the facility managers who will run the building decades from now.
How does that go wrong?
Well, if the engineering model calls a specific light bulb fixture type A, but the hospital's maintenance software calls it lumen source 1, the data is completely useless to the guy trying to order a replacement bulb. Aligning that naming schema across thousands of parts is incredibly tedious, boring work, but it ensures the building is actually manageable for the next 50 years.
And they mention ISO 19650 workflow enforcement, which I have to say sounds like the ultimate corporate buzzkill.
I know, it sounds impossibly dry, but ISO 19650 is the gold standard international rulebook for managing digital information. Following it rigorously is a form of deep professional discipline.
It stops you from cheating.
Exactly. It strictly prevents you from taking easy shortcuts. It's the rigid liturgy of the digital covenant, if we want to keep playing with their theology metaphor.
And then there are CDE governance cycles, CDE being the common data environment.
That's the digital vault. The CDE is the single undisputed source of truth for the entire project. Governance means strictly policing that vault, making sure no contractor uploads an unverified file, making sure no one accidentally deletes the design history. It's fiercely protecting the integrity of the project's central brain.
The source paper sums this all up with a quote that I genuinely think should be printed on a poster in every single engineering office in the world. They wrote, "Concrete does not fail because steel is weak. Projects fail because coordination was weak."
It's a very bold claim to make, but statistically speaking, it holds up perfectly. Material science is actually remarkably good today.
Right? We know how materials work.
We know exactly how steel behaves under stress. We know exactly how concrete cures in different weather. When a modern building fails, whether it literally collapses or it just goes 50% over budget and bankrupts the owner, it is almost always a failure of basic communication, a failure of coordination, a failure of truth successfully moving from one person to another.
So the true strength of the building isn't just found in the physical rebar holding the concrete together. It's in the flow of information.
The information is the structure. The steel just dumbly follows the instructions it's given. If the digital instructions are weak or flawed, the strongest steel in the world is useless.
This really brings home the whole resurrection idea they started with. They're saying that if you actually do this Good Friday work, this intense suffering, this heavy sacrifice of data entry and endless clash resolution, the final result is a physical building that performs exactly as it was meant to.
It provides absolute certainty. The best engineers don't hope the building stands up. They know it will.
Because they've already built it.
Exactly. They've already built it digitally. They've already experienced and solved all the critical problems. The physical construction process is really just a real-world reenactment of the digital truth they already created months ago.
It's almost like a form of technical prophecy. You're writing the exact history of the building before it even happens.
That's exactly what good engineering is. It is prophecy backed up by rigorous math.
So, Roots BIM LLC concludes this entire reflection with a powerful synthesis. They state that strong buildings are born from discipline in modeling, integrity in data, transparency in coordination, and faith in process.
Faith in process. I think that's the crucial bridge here. You really have to trust that the hundreds of hours you spend just staring at a monitor, fixing highly abstract geometric clashes will actually manifest as a safe, beautiful, physical structure.
Because you can't see the payoff yet.
Right. It takes immense faith because you cannot physically see the reward while you're doing the most difficult work. You just have to deeply believe that the process itself works.
They write at the very end, in both faith and engineering, the greatest strength is often invisible.
And that is a universal truth.
Right.
The physical foundation of a skyscraper is buried deep underground. The structural rebar is permanently hidden inside the gray concrete. The coordination data is hidden inside a server rack somewhere. But those are the exact things that hold the entire world up.
It really makes you look at a city skyline completely differently. You look up and see the beautiful, shining glass and the sleek steel, but you don't see the millions of painful resolution loops that made it stand up straight.
We always celebrate the visionary architects who draw the beautiful napkin sketch. But we rarely, if ever, celebrate the exhausted BIM coordinators who stay up late figuring out how to keep the hospital toilets from flushing directly into the air conditioning system.
Well,
But without those coordinators, that brilliant napkin sketch just stays a sketch forever.
so let's turn this entire concept back to you, the listener. You might not be pouring industrial concrete or running advanced 4D clash detection software, but this core concept of the invisible load-bearing layer applies literally everywhere.
Absolutely, it does. Every single job has a clash matrix of some kind. Every profession has that incredibly tedious, unglamorous suffering that is absolutely required to make the final product actually work.
So the real question you have to ask yourself is, what is that invisible layer for you? What is the specific coordination load that you have to carry in your work? And crucially, are you treating it as merely ornamental? Are you just going through the motions to make it look like you're working hard?
Or are you treating your process as a true digital covenant? Are you making a binding promise that your underlying work is true, even if absolutely no one ever sees the complex spreadsheet you're working on?
Roots BIM LLC leaves us with this final, incredibly provocative thought. Precision isn't just about being fussy or pedantic. It's actually a profound form of foresight. Every single resolved clash is a prevented future cost. Every validated element is a mitigated human risk.
Building strong infrastructure, whether you're talking about a hospital building, a startup business, or honestly even a life, relies entirely on the strict discipline of managing the things the rest of the world cannot see.
A truly powerful thought to end on. I have to admit, who knew a standard PDF about construction specs could get so deep?
It just goes to show, sometimes the hardest, most vital truth is hidden in the absolute driest technical manual.
That's a wrap on our deep dive into sacrifice and structure. Thanks for listening, and we'll catch you on the next one.